Hello everyone. In this lecture, we will give some examples of signal analysis in time domain. For this example, it has 3 questions. Given the waveform of a continuous time signal SOT, you should represent the signal with UOT and ROT. Here is the solution. The representation can be expressed in this equation. For details, you can practice after the class. The second question is listing the mathematical form of the first derivative and plot the waveform. Now let's give the waveform of the first derivative. For this point, it is a discontinuous point. Thus, the first derivative is a dirt signal, and the strength of this dirt signal is 1 minus 0, thus it is 1. For this part, the slope for this signal is minus 1, thus the first derivative is equal to minus 1. And for this point and this point, they are both discontinuous points, thus the first derivative for these 2 points are dirt signals. For these points, the magnitude change is 1 to minus 1, thus the strength is 2. For this point, the magnitude change is 0 to 1, thus the strength is minus 1. Here is a mathematical form of the first derivative. We can get this form from the waveform. For example, this signal is dirt of t plus 2, and this signal can be represented using these 2 parts. And similarly, these 2 signals are represented using this formula. The third question is plot the waveform of x of minus 2 times t minus 4. Here is the solution. We first compress this signal by 2 times, and we get x of 2 times t. And then we do the time reversal, and we can get the result of x of minus 2 times t. And finally, we do time shifting on this signal. That is, shifting this signal to the left by 2 times, and we can get the final result. Here is another example. It has 4 questions. The first question is represent SOK with the unit impulse sequence. Here is a solution. For this value, it can be represented using dirt of k minus 1. For these values, it can be represented as 2 times dirt of k minus 2. The second question is representing SOK with the unit step sequence. Here is the solution. For details, you can practice after the class. The third question is finding the difference of SOK. Here is the expression formula of difference. So we should first find the sequence of SOK minus 1. Here is the result. And then we can get the difference of SOK shown in this formula. The fourth question is plot the waveform of the sequence of x of 2 times k minus 1. Here is the solution. We first shifting this signal to the right by 1 unit, and we get SOK minus 1. And then we do 2 times decimation on this sequence, and we can get the final result. Here is another example. Given the waveform of a signal, you should plot the waveform of signal of x of 4 minus 2 times t. We can use the function values at the terminals are the same before and after the transformation. Here is the expression formula. In this equation, T1 and T2 are the terminal points for one signal, and T sub 11, T sub 22 are the new terminals for the other signal. By substituting these two signals, we can get the new terminals for this signal are defined as T11 and T22, and they should be satisfied with these two equations. And finally, we can get the two new terminals as 1 and minus 3. Thus, we can get the final result for this signal. Here is another example. Given the waveform of SOK, you should find the odd part and even part for this signal. So we should first get the sequence of x of minus k, and then we do summation on these two sequences. We can get the even part. And by applying subtraction on these two sequences, we can get the odd part for SOK. Here are the final results. Now here are some exercises you can practice after the class. In this exercise, the content is the properties of the imaginary exponential signal and the sine signal. For this exercise, the content is the similarities and dissimilarities between the imaginary exponential sequence and the continuous time imaginary exponential signal. For this exercise, the content is a relation among UOK, delta OK, and ROK. In this lecture, we give some examples of signal analysis in time domain. That's all. Thank you. See you next time.